this video, we are going to explore the Quaternary geology of an area east of Cambridge in southern Ontario. In previous videos, we looked at the geology near and around the Waterloo Moraine. Then we went to Conestoga Lake area and then southwest to Woodstock. Now we are going to look at the eastern end of the regional cross-section I showed before, and look at features like the Paris-Galt Moraine and related features such as Proglacial outwash and the subglacial environment behind the moraines. The stratigraphic architecture of the Paris-Galt Moraine shows in places evidence for ice advances over an outwash plain, as we see thick till sheets forming a few ridges with hummocky topography overlying tabular sheets of gravel that are very extensive laterally. Here you see a superficial geology map of the area that shows in green the moraine ridges made of till and their superficial relationship with the extensive outwash plains in orange. A 3D model was also developed for the area using available data to further explore the stratigraphic architecture of the moraine area. Overall, the tabular sheets of gravel extend laterally along the moraine ridges for several tens of kilometers and are thus comparable in size to the extensive outwash plains we see in Iceland today. But the fact that outwash plain sediments are partly buried under the till sheets of the moraine ridges indicate the Ontario ice slope advanced in this area during the glaciation over its own outwash plain sediment. So now let's take a closer look at the superficial till of the area that was deposited during this time of moraine buildup. Hello, we're east of Cambridge and we're on the Paris-Galt Moraine. And the Paris-Galt Moraine, as you can see, is a hummocky topography, and at the surface there's a thick till that's associated to the re-advance that created that moraine, and this till is called the Wentworth Till. Now we're going to take a closer look at the Wentworth Till. The Wentworth Till on the Paris-Galt Moraine has a fairly high class content, and it's got boulders like you can see here, and again you can find all the typical subangular polished and striated clasts. One thing that is interesting about this till is, as you can see, the matrix in some places, not everywhere, but in some places the matrix has a reddish color to it, and that is because in the source area of that till, is around the Hamilton, Niagara Escarpment area, where you find rocks like the Queenston shells that have reddish layers, and so it's hard to find class of these shells because they're not very hard and resistant to glacial transport, but the matrix itself sometimes has this reddish color. All right, so we're just south of the ice contact side of the Paris-Galt Moraine. Very close to it, and bedrock is already outcropping here. Gives us an opportunity, a really nice opportunity, a rare one in the region, because there aren't many places except around this area east of Cambridge where bedrock is outcropping. So that's why it's the first time we talk about this on the last field trip. So, but here we are. So we have a good opportunity here to look at the effect of sliding on basalized sliding onto bedrock. So you see the effect of abrasion here, and so when you have debris-rich ice, you have the concentration of debris in contact with the bed, as we discussed in class. You have the so that concentration of debris that are same or harder than the rock itself. So this is carbonate rock, so it's really easy to abrade. So it creates this nice polishing. You have the contact force of the particles onto the bed, and it's there's the velocity of the particles. The particles as they are being dragged along it. So this is the up ice side. It's the abraded
stoss side of the outcrop. And we also talked about quarrying, which again is the two-step process of failure of rocks and plucking and entrainment of these rocks down ice. And so once again, you see the nice effect here. So you can imagine a subglacial cavity. There's the step. You had the cavity, and then it reconnects until it hits the next one. So all of these are important factors. And then you can see that there are some joints in the rock as well. So that can certainly help the process. And as we discussed, one important factor here, yes, there's sliding velocity, but also there's the water pressure variation or fluctuation. So we haven't talked much about subglacial hydrology yet, but you have to picture this situation where when you have a down ice subglacial cavity, it can fill with water, and that's going to increase the pressure, but then it can drain. And again, if you have the right conditions, the cavities can fill and drain repeatedly, and that will change the effective stress at the crest of the outcrop here. And so you have these intense pressure fluctuations here, and that will certainly encourage failure, or that this is where the rock is likely to fail, and especially if water can infiltrate those cracks and so on. And so this is an important process in generating till. It certainly is responsible for generating a lot of the coarse-grained particles in till, but as those particles get transported, they can be crushed and further comminuted, so they can contribute as well to produce matrix. And of course, abrasion is creating matrix as well. So this is a nice example. Now let's take a close look at the ice flow direction.
For this, you can use a compass or a smartphone and measure the azimuth of the striations in the down ice direction. So here we got 321 degrees, so a northwest direction for the Ontario lobe, and that is nearly perpendicular to the Paris-Galt Moraine. So this is showing ice flow direction during the time interval of Wentworth Till deposition and Paris-Galt Moraine built up in the area. Now we can see that this map is showing an interesting track of sediments and landforms that are relatively contemporaneous, with sedimentological environments that were juxtaposed next to one another. On the left side of the map, you see the proglacial outwash environment, again in orange. You see the ice-marginal to ice contact moraine environment around the Paris-Galt Till ridges. And we see on the right side the subglacial environment with striated bedrock and till drumlins. So now let's take a look at those till drumlins.
So we're just south of the Paris-Galt Moraine in a drumlin field. There aren't too many drumlins in the area, and some of them are isolated, like the one behind me. This one has a moderate amplitude, so several meters of Quaternary sediments, mostly Wentworth Till, and but yet around, very close to the edge of that drumlin, around it, there's very thin deposits, and you hit bedrock very quickly. Actually, bedrock outcrops nearby, so there are some bedrock outcrops around the area. So the fact that bedrock is outcropping in a lot of places around those isolated drumlins that are several meters thick of Quaternary sediments, that's an indication that erosion played a role here in not only the formation of drumlins, but also in eroding material and advecting a lot of that material towards the Paris-Galt Moraine during the Wentworth re-advance.
So the area east of Cambridge contains an interesting assemblage of sediment and landforms that record ice margin retreat and short re-advances, outwash plain sedimentation, and other things related to the general deglaciation of a glacial lobe that used to occupy the Lake Ontario basin. So this completes virtual field trip number 4, which is also the last field trip of the series. So I hope you enjoyed learning about the Quaternary geology of the Waterloo region and surrounding areas. Thanks for watching.